Alright, so as before, we start by building our triangle here, and that should be some unknown length. A 20-degree angle, it's going to be a fairly sharp angle, and A, that's angle A, so this is side B, is 31. So that's exactly 31 right there. And then where is A? Well, it looks like A might be able to reach. Now, if 12 is too short, there'd be no solution. If it's exactly the height, we're just going to have a right triangle. And if it's longer, it's either going to be an acute angle or an obtuse angle. So if we look at this, I want that to come down here, we need to know what the height is to know about how many solutions we're going to have. So we can just figure out this. H equals B times sine of A, and that gives you approximately 10.86. So we have this case where A is 12, B is 31, so A is between 10.9, let's call it, and 31. So we're going to have, and A is an acute angle at 20.5. So we're going to have two answers. Alright, so we know we have the ambiguous case with two answers. So what we're going to do is first figure out what our other angle is going to need to be. So we'll do the acute angle and then the obtuse angle. So let's go to the prettier drawings. Oh, those already have too much salt on them. Alright, so we want to know angle B, or angle B rather here. So that's right here. So I'm going to do sine A over A equals sine B over B. Sorry for the messiness. And that's going to give you sine of 20.5 over 12 equals sine of B over 31. I'm going to multiply both sides by 31, and then that gives us 0.9047 blah blah blah, and we're in degree mode, so that gives us approximately sine B is approximately what was that? 0.90 whatever. And then to get the actual angle B, we need to do the inverse sine of both of those. So I'm going to do sine inverse of this answer. So I don't have to round anything. I can keep it exact by doing this. That gives me 64.78 degrees. So 64.78 degrees is approximately angle B. So I should write measure of angle B. So then that would make this 64.7 degrees. So you can subtract these from 180 and find this one, and you can use the law of sines to find the third side. Alright, and then the other angle, since it's like this, we have the alternate setup where this is 12, 31, A, B, C here. We know all this. Since this is actually the 64.7 side, and then this one is an obtuse angle, so that's going to be 180 minus 64.78, and that gives us our other angle. What is that? 115.2. 115.2 degrees. So that's our other one. So here's a nicer version of the two triangles. When you solve it, you get 68 degrees or 115.2 degrees. And then you can use those to solve for the missing side and angles.